Symbols matter. The problem is that in many cases we become so attached to the symbol that any criticism of the Kyoto architecture becomes impossible, because criticism of Kyoto is regarded as criticism of doing something about climate change. And let me be very clear, I'm not talking about inaction. I'm talking about trying to find the right kind of action. The Kyoto Protocol, the Kyoto architecture, was based on fundamentally flawed analogies with a number of precedents that were available to policymakers at the time, chief among which was sulfur trading in the US EPA sulfur trading program and the global stratospheric ozone regime. And what we got from sulfur trading was the idea that an economically efficient way of reducing sulfur emissions in the United States was to allow utility companies to trade their emissions among themselves. It worked very well. But it was a small set of actors trading one gas within one legal system that could enforce contracts. The Kyoto architecture envisages multiple gases, multiple sources and sinks, and trading among countries in a condition in which there is no real sanction for defaulters. So Russia sells all its hot air and then says, sorry, we can't meet our emissions quotas. What are we going to do? Invade them? Make them subject to a trade ban? I don't think so. We need their gas. The global stratospheric ozone regime. It was a small set of industrial gases for which there were readily available alternatives at the time, and there were few countries with few producers. Very different from trying to deal with carbon dioxide and other greenhouse gases, which are ubiquitous, global, and arise from multiple processes. So the Kyoto architecture so far represents 14, 15 years of negotiation. Its original 5% targets for countries have been watered down to about 2% in real terms. There's little realistic assessment of how you ramp that up to the numbers around about 80% that people are currently talking about. It isolated and demonized the US. There was no viable strategy for dealing with India and China. I could go on with the flaws of the Kyoto approach. So in trying to present to you the nature of the problem and to why exactly carbon trading won't work, I want to give us an idea of the scale of the problem. This is a graph taken from the Intergovernmental Panel on Climate Change Working Group 3 assessment. I was a member of the panel that produced this assessment. So the criticisms that I'm going to make of it are a mea culpa. They're not sniping from the sidelines. If we look at this graph, which shows on the vertical axis the temperature ranges, the temperature increases that are expected from increased concentrations of carbon dioxide in the atmosphere arising from different developmental and economic scenarios over the next 100 years. We can see that the potential ranges from something about 1 degree, which many people would say actually is within the noise of normal climatic variability, nothing much to worry about, to as high as nearly 6 degrees. The bad news is that since these were produced some years ago, global emissions have been increasing at 3.5% per annum. That means that we're actually on an emissions trajectory which is headed towards the upper bounds of this range. It's probably going, according to this projection, it would be leading to temperature increases in the order of 4 degrees by 2100, 2 degrees by 2040. Please keep that date 2040 in mind, okay? Fix that one. Even if we stopped emitting in 2040, temperatures would continue to rise because of the momentum in the climate system. And let me point out that these temperature increases actually are just from human activity. They don't include potential carbon cycle feedbacks that could lead to releases of methane and carbon from soils and so on and so forth. So what this suggests is that given current emissions trajectories, we're in the upper bounds of this picture, but it's worse than that. The IPCC may have severely underestimated the scale of the problem, because all of those scenarios that informed the graph I just showed you assume that a 140-year trend, which has been going on, will continue indefinitely. And that's a trend of decreasing carbon intensity per unit of global GDP. Okay, so for 140 years we've used less carbon for each dollar, pounds worth, euros worth of value that we've created. Until 2 years ago. 2 years ago, that trend stopped and has inflected. Now, you can say that's just a blip, or you can look at that and you can say that's China and India. And if it's China and India, as this graph suggests, the total avoided emissions you would need to achieve by the end of the century to stabilize carbon concentrations in the atmosphere would be more than twice what the IPCC currently suggests. So how are we trying to deal with this? We're trying to deal with this through a global cap and trade policy. Now, I'm not an economist. As I said, I'm a philosopher and an anthropologist of sorts, or an undisciplined social scientist, as the rector said. But this is my very simple-minded representation of the situation, what we're trying to do. At the moment, we've got very cheap carbon-based fuels along the bottom curve and expensive alternative energy technologies along the top curve. And what we're trying to do is to establish a carbon price, which you could, by the way, do by a carbon tax. But we've decided to go largely for a cap and trade system, whereby as you ratchet the cap down, the value of the permits goes up, and therefore forcing the price up. It's a logic, by the way, that seems to have escaped Congressman Waxman in the US, who recently went on television in defense of the Waxman-Markey bill, assuring Americans that it would not result in increased fuel prices. I don't see the point in cap and trade if it doesn't actually put the price up. It's supposed to be a price mechanism. That rising price is supposed to send a signal to the people who are involved in the industrial activity that produces the alternative energy technologies to invest in research, development, demonstration and deployment, R&D, D&D, of those new technologies. In particular, to stimulate technologies which exist but are currently just too expensive, to bring them to scale. Okay, so we're not talking about inventing something new. We're talking about taking existing technologies and getting them to the point where their price starts to come down. So we wait for that signal to stimulate the R&D, D&D, and indeed eventually bring down the price as we're ratcheting up the price of carbon. The curves intersect far out to the right there, and at that point, according to my understanding of economic theory, we expect, and innovation theory, we expect then the non-carbon technologies to rapidly displace the more expensive carbon-based technologies. Now, I'm willing to go along with the idea that if there were no time constraint, we could eventually develop an environmentally effective, economically efficient global carbon market. But it took 300 years to develop a really efficient international currency market. And let's not make any mistake, under cap and trade, carbon permits are a new international currency. Okay, so this isn't a completely spurious parallel. Let's say we can improve on that by a factor of 10, 30 years. Okay, we've had 10 years so far to get to the European trading system to the parlous state it's in, where the price has collapsed twice already. But let's say we can do that in 30 more years. That brings us to, oh dear, 2040. Game's over, guys. So my argument is you can't get from here to there